Each of the presentation will be jointly presented by me and Salim. So the first one, we will talk about the familiar interface for the peer-recorded ground motion database, or the NGA, that's used by many users, and what are the differences between this existing one and what will happen with the simulated ground motion database, and what are the bases of any changes or similarities. So you all have seen this poster, it's still sitting outside. So this work, like the EQ Sim, is a collaboration by many people, not just me and Salim. So the acknowledgement of the people was in this poster, so I won't repeat it here. So basically, this poster is the foundation of what we are presenting in these two talks. So in the first talk, we will have a quick introduction, and then we will talk about the recorded ground motion databases that we have, and then what's our plan for the simulated ground motion database based on the EQ Sim work. So just looking a little back in the past, when earthquake engineering fundamentals were in the making, the good old days when people used to work in design offices that look like this. Nowadays, people use computers and try to come up with ductal response, or look at other performances, collapse prevention, saving lives and whatnot. And then we have seen this picture so many times of the, which still with all that interest in regional scale modeling and trying to come up with performance criteria that is based on functional recovery and resilient communities, and with all that incredible computing power with these supercomputers, we don't want to be left out, and by we I mean the engineering community. So whether we're going to come at the end of work done by Lawrence Berkeley Lab or Lawrence Livermore, or we could be part of this large-scale simulation, we need to be there. And that's why we are very excited about this work, is to include such a database within the peer and make it available to our peer community. So, as you all know, performance-based earthquake engineering, and now it talks a lot about resilient design and so on, is pretty much the DNA of PEER. We started this back in mid-90s, and it still continues to be what PEER does, looking at performance of our built environment, starting with the most important step was this, which is the hazard analysis, and then going to the structure analysis, to damage analysis, and then to the loss estimation, using this famous, now became iconic triple integral that puts a unified foundation of how these four steps come together. So certainly the hazard analysis is a very important step, whether it's done using recorded motion or using simulated motion. So the objective of performance-based earthquake engineering is to estimate system performance, whether this system is a building or the entire electricity grid, accounting for uncertainties. So you need to do a lot of simulation. You need a lot of realization of the ground motion so you can take into consideration this uncertainty. Defining hazard and selecting ground motion is in the heart of this methodology. Accessing the ground motions that only were recorded were for a long time hampered by collecting and manipulating big data. And in the late 90s, PEER improved this accessibility by developing these NGA databases. So a little bit, I'm not going to go into details of how this data, well, let me get rid of this. How do I hide this? Oh, hide that. Hide video panel, is that?
Yeah, hide the...
Oh.
No.
What should I hide?
Hide the moving controls.
This one, yeah, okay. So how was this ground motion database was developed is ground motion records were collected worldwide. They were processed in a consistent and reliable manner, and then metadata, whether it is the source, the site, the magnitude, type of faulting, various source to site distances, local site conditions, and so on, were all collected and included in the database. And at the end, you have things like this, that a few screenshots of the different recording stations, the description of what the PEER database has, and then you have this flat file that has all the metadata about this recorded motion. And this is open source. It's accessible to the community, whether they are practitioners or researchers. So then why we need simulated ground motion? We have seen this figure multiple times now, so hopefully this will be the last time you're going to see it. But basically the summary of this picture is that it tells you there is a scarcity of the recorded near faulty ground motion for large magnitude earthquakes. So if we're going to speak about extreme events and looking at how resilient our built environment is, you need more data in this yellow box. You have insufficient recorded ground motion to conduct regional scale modeling, which now clearly is of interest to many groups. There is a lack of the ability of most ground motion models to capture the effects of rupture propagation. We heard a lot about source modeling and rupture propagation, such as directivity and so on. So if you're going to rely only on ground motion, you could be missing some of the important physics that the seismologists and also engineers know a lot about. So the increased number of these validated ground motion simulation from multiple regions, from Italy, from United States, and so on, and Turkey, is there. So why shouldn't we as a peer community not to be part of this ecosystem? So clearly there is a need to develop such ground motion database and make it available to researchers and practitioners. So what are the requirements for a successful database as such? Basically two things that were also mentioned by others. I think David mentioned that, is scalability, which means you have to have a large storage server somewhere with regular maintenance and backup. So we looked at what resources we have with support from DOE, and we were able to come up with a reasonable plan of an initial start of up to 95 terabyte of solid state disk that we can purchase and be able to absorb, at least for a few years, what this database is going to look like, with a possibility in the future to actually double that. So we have been, hopefully, this disk space over time, there is no point of buying huge disk space now that can take 200 terabyte of data, because hopefully in the future the price of this will go down and we will be able to scale this up even at a less cost than what we can do now. The second point is we have to have a procedure so we can expand the database with new data, including an effective web interface with well-defined search options. So Hongjun mentioned, and also David, about the size of the data and the capabilities of compressing the data. And we looked at the two scenarios of having part of the data that is compressed, or the majority of the data that could be compressed, but also part that could be uncompressed. And we came up with a reasonable plan that you see in this table that we can achieve both options within that storage space in a realistic way with the available resources. So that's what we started developing, is to acquire this hardware so we can have this data available to our community. And then the second point is the existing interface. So if you go to the PEER website and you access the NGA West 2, you're going to see something like this. So we are planning basically to add another icon that focus on the simulated ground motion database, SGMD, and we are aiming to make the well-known NGA interface to be also usable for this new data set in a seamless way. As much as we can, of course, there has to be some differences that we will point out in a second. But before we started doing this, and David mentioned the feedback we get back in 2021 on the forum that was held, there was also a survey that we conducted in March 2022 when we started thinking about this database. And we get good feedback from maybe some of you participated in this survey. So the first question was, what simulated ground motion data products would you like to have readily available? And we got 71 responses that for these two items. People wanted to see acceleration, velocity, and displacement. They want to see NGA type flat files. And that was the majority of the feedback we got there. The second question was, what would be the most convenient simulated ground motion data and metadata format? So the majority wanted to see something, again, similar to the existing PEER format or in some sort of a text file. So that's what we get in that regard. The third and last question was, what would you want the user interface to look like? And then the overwhelming majority is something similar to the existing NGA, or something similar to the existing NGA with a slight modification. So in response to this feedback we get, that's what we are planning to do. So I'll pass it on now to Selim to talk about what is the existing interface and what are the differences with the expected new data set.